We have discussed the 2022 September FN paper yesterday. So today we will be doing the 2022 September AN paper. So this paper is similar to the FN paper. So many questions are same and some questions are similar, but the options and some minute details are different. So let's start with this paper. The statement of the everything is visible.
Yeah, it's
Yes, sir,
visible.
we can do that.
Okay. Yeah. So in the first question, this is similar to the first question, but here there are some differences. So here you can see everything else is same, but instead of having the E in the second option, we don't have the minus E. So the minus E enables us to use backslash characters like backslash N for new line and backslash T for tab, etc. So in this, we only have backslash N. So we are not printing the new line by default at the end. And because we don't have backslash E here, so this backslash N is also not printed as a new line. This is printed literally. So for example, uh, one second, just give me 1 minute. Yeah. So for example, if I run this echo command with a backslash N B, so you can see that it will simply print the backslash N, and only if I use the minus E will it actually treat this as a new line. So in this question, we don't have the minus E, so this will print this backslash N as the literal character. So what we will be printing is a star and then followed by a space, and then because we have minus N, so there is no new line, so we are in the same line, and then again another star, and then the backslash N will be printed literally. So this will be literally printed backslash N, and then star backslash N star. So again we have a star, and again backslash N, and then again a star. And then we have a space here, and then again because we have minus N, so there is no new line, and then again we print a star and a space. So this is what is printed. So everything is printed in one line. So this is basically star, star, then backslash N, star, backslash N, star. So this is like near each other, and then space star. Right, so this is the correct option, and there is only one option which has the backslash N. So other options do not have the backslash N. So this first option is what was correct for the other paper where we had minus E, but because we do not have minus E here, so this is not correct, and we have the literal backslash N in the answer. Right, so I think no, sorry, not the first option. The fourth option was the correct for the other paper, and in this one we have the third option correct because we don't have the minus E. Right, so hopefully this one is clear. So let's move on. So this is the exact same question. So here we are asking whether to use a soft link or a hard link when we want to point to a folder in a like USB pen drive. So a college student stores files in a pen drive, and it is always mounted at /mount. So the path is always same, and he wants to basically create a soft like he wants to create a link to this path /mount, and then this folder where he has a lot of files, and he want to store it in his home directory, right? So because this is in a different file system, and also because this is a directory, so first of all you cannot create a hard link on a directory, and secondly you cannot create hard links across file system. So we cannot use hard links in this, so we will be only using a soft link in this case. So because of this, in this question the answer is soft link, and because hard link is not possible, and fourth option is not correct because soft link is possible and it is a valid solution to this. So even when he removes the pen drive and the file no longer exists, the link will still be there. It will be broken, so if he tries to open it, it will not open anything. But again, as soon as he plugs his pen drive back in, the link will again start to work. That is because soft link uses the path and not the actual file's data. So whenever that path has some file, it will again resume working. So that's why soft link is the correct option in this. So Let's move on to the next question. So this also is like the given
Sorry
sequences.
to
Yeah,
interrupt.
yeah.
You covered this yesterday, right?
Yeah, so this is the other session of this. So some questions are same and some questions are different. So
Okay.
uh, like in the first question, here we do not have the minus E. So here we are printing the backslash n literally. Whereas, so in the question 2 and 3, it is same. So I'm not explaining it much because we have already covered this. So this one also is the exact same as we had in the other paper. So G goes to the last line and dollar goes to the end of the line.
Correct, correct.
Then we insert the visual mode, enter the visual mode, and then we go to GG, which is the first line, and 0, so the first character of the first line, and then Y yanks the entire selection. So from the last character till the first character of the entire file. Then capital G again goes to the last line and P prints that. So whatever was copied, which is the entire document, is printed. So in the end, we have basically 2 copies of the initial document or the entire document. So that's why we have the option 4, which is the correct option in this. So let's move on. So in this question, now this is similar, but we have some differences here. So here the difference is that we have this 1 greater than ampersand 2 line in this after echo. So earlier we saw if we did not have this, then this would basically store everything to file 2. And because stdout will then be empty, so T will not get anything and file 3 will be empty. So that is what we saw in the previous paper. But now in this paper, what we have done is the echo, which basically prints out each line from file 1, right? So the file 1 is taken in standard input and it is read by the read and stored in a line by line. So when it is echoed, that is redirected not to standard out, but into the standard error. So from the standard out, it is redirected into the standard error. So it will still obviously output to the screen because both standard out and standard error by default mounted to the screen. And here, when we are redirecting to file 2, so this default redirection only redirects the standard out. So here, everything that we are printing is on the standard error and nothing we are printing on the standard out. So thus, there is nothing in the standard out. So when we are redirecting to file 2 will actually be empty in this case because there is nothing for us to redirect to file 2. And similarly, when we are piping it to T, so pipe also gives the standard out. So the standard out of this command is given a standard in of T. So as we just now saw, standard out is empty for this while loop because everything we are printing to the standard error. So T also gets nothing to the screen. So neither can T store anything in file 3. So the file 3 will be empty. And it will also not print anything to the screen. So T will also not be able to print anything to the screen and file 3 will also be empty. But because we are redirecting it to standard error, so that standard error will be printed to the screen. So in the end of executing this, file 2 will be created but will be empty. File 3 will be created but will be empty. And the output of file 1 will be printed to the screen. So let us run that and see. So let me write something in file 1. And then if we do this, while read line do, so here we are doing echo dollar line, and that we are redirecting the standard out into the standard error. So this means standard out is redirected into standard error. And then we are basically reading from file 1. So if we just do this, then as you can see, because both standard out and standard error are printed to the terminal by default, it makes no difference to our eyes when it is simply printed. But when we are redirecting, so redirection is only done using the standard out. So like the default one. So if we redirect this to file 2, this will actually not redirect anything. So it will still print hello to our screen because of redirecting to the standard error, and file 2 will be empty. Right? So right now you can see there is file 1 and file 2 is empty. Now if I on top of this add the T file 3, which is what we have here. So anyway, the standard out was already empty. So T will anyway not get anything. So file 3 will also be now created, which will be empty. And T will still not be able to print anything to the screen. But the printing will be done by this redirection to the standard error. So now the standard error is printed to the screen. And we have now 3 files in our directory. File 1, which remains as it is. File 2, which is empty. And file 3, which is also empty. So that's why in this question, the options which should be correct is file. So both file 2 and file 3 will not be empty are incorrect because both will be empty. And the contents of file 1 will be displayed in the terminal is correct because due to redirection to the standard error, the content is displayed. So it is not displayed by the T command, but it is displayed directly when we are echoing it into the standard error. And file 3 also will not contain the contents of file 1. So only the option 3 is correct. It's hopefully this is clear how this is working and how it is different from the yesterday's one. So because now we are giving everything to standard error, so the default redirection does not redirect anything. So by default, it will only redirect standard out. So as standard out is empty, so nothing is redirected. Right, so let's move on to the next one. So in this question now, we are asked to choose the regex that will match a string that contains at least a character repeated 3 times consecutively. So in this paper now, they are asking consecutive repeatedness. So only if the 3 character is like a character is repeated 3 times consecutively. So in this now, we will not use the dot star in between the back references. So we will match the character with dot inside brackets. So this is ERE, extended regex. So we will match it and group it using the group, and we will reference it using the \1. But now because we want it to be present consecutively only, so only this option is correct, and this is now not correct anymore. And as for same reasons as the other paper, the first and second options are also incorrect. So, and the fifth option is also incorrect because here again we are using dot star. So here we only want strings in which they are repeated consecutively. So hopefully this one is clear. All right. So in this, so this is almost very same, but instead of 2 ends, we now have 3 ends. So what does the given set script do? N command in set appends the next line to the pattern space with a new line being the separator. So we saw if we have one n and we substitute the \n with nothing, then 2 lines will basically be put side by side. Right? So if let's say we have a file, and if let me open multiple panes, and if I do this sed n and then substitute the \n with nothing, and if I do this on the data.txt, so you can see every 2 lines will be concatenated side by side, and like if there are like odd lines, the fifth line will remain as it is. But if we have 2 ends, we are basically appending 2 lines into the pattern space. So first 3 lines become part of the pattern space in the first cycle itself. And because we're substituting all the \n with nothing because of this G, so all of them will become side by side. So we will have 3 lines side by side. Hello, how are you? This is line 3. And here, so why is this is line 4 and this is line 5 not consecutive? Any idea, anyone? So the first 3 lines are put side by side, but the fourth and fifth are not.
Got it, sir.
No, but why is this happening? Because I'm using 2 ends, so it should take 2 lines into the pattern space. Right. So for the first line, it's taking second and third, and it's making it side by side. But then it runs again for the fourth line, but it is not taking the fifth line side by side. Any idea why this is happening?
So this N stands for line, the
So
capital N.
capital N basically will append the next line in the pattern space. So usually sed will only have one line in the pattern space in each cycle, but using the N, we can append the next line into the pattern space also. So after the first N, this entire thing is part of the one pattern space in that cycle.
So in this case, we are giving it, it takes line because it executes line by line with 2 capital N. It
Yeah.
takes, it keeps appending twice. So that's
Yeah.
why 3 lines will come together. And after that, we aren't giving any other end. So that's why for that particular line, it just does the command that we've given, substitution command. Then it goes
Okay.
to the next line again.
Yeah.
But there, this command doesn't execute then.
Okay. Okay. So you're close. So the reason is because in the first line, when I run the first n, it takes the next line in the pattern space. When I run the next n again, it takes the third line in the pattern space. And then the substitution will basically remove these new lines. So it will make it side by side. Then in the next cycle, it will start here. And when I have the next n, it takes this line in the pattern space. But because I have two n's and there is no more line after this, so the GNU said, which we are using, so the GNU said that if it has n command at the last line, it will not throw you any error, but it will simply stop that cycle. Right. So because I have another n, but there is no more line after this, it will not just like not throw any error, but it will also totally stop that cycle. So any command given after it, like this substitution, will also be neglected. So this will basically not do it at all. So is there any way so that we can change this command so that this still will do this same thing? So 3 lines will be taken side by side, but in case at the end we only are left with 2 lines, then 2 lines will be taken side by side. How can we change this script? Any idea? No? So right now it's basically not being able to come to this substitution because this n is telling there is no more line. So just stop this cycle totally. So the next command is not read at all. So how can I avoid this? Any guesses?
I think we can add another line to the file, then it will work.
No, that is fine. But in case like we don't have like that, so in case the file has 5 lines and the output that I want is first 3 lines are side by side, and if we don't have 3 more, so we have 2 more, so the 2 lines should be side by side. So it should be this is line 4, this is line 5. So without changing the file, how can I like by changing the script, how can I accomplish that? So this is clear, right? So why this is happening? Because we have like the second n is not able to take any more lines. So this is basically stopping the script in that line. So what we can do is basically instead of doing the global substitution at the end, we can basically do 2 substitutions. I can do substitute \n with nothing, and then again read another line and again substitute \n with nothing. Right? So doing both the substitution instead of doing it in one command, I'm basically doing it 2 times. So first read one line, like read the next line, substitute the \n between the current and the next line with nothing. Then again read the next line and substitute the \n between this and the previous line with nothing. So now you can see the 3 lines are side by side, and after that we only have 2 lines. So the 2 of them are side by side, but it's still like doing them. So this is because in the first cycle all the 4 are executed, and in the second cycle the first n is executed, then this first substitute is executed, due to which we get this output. Then this second n is tried to execute, and because it fails, then basically this cycle stops. So this is not executed. So hopefully this is clear. So in this question, we basically have 3 n's. So instead of 2 n's, we have 3 n's. So if we have 3 n's, then basically 4 lines will be put side by side. So as you can see, the first 4 lines are put side by side. So if we have more lines also, they will also be taken side by side. So that's why the answer to this is merge every 4 consecutive lines into a single line. But hopefully this is clear how n and like substitute works.
Yes, sir.
All right, so let's move on. Okay, so this is
So,
the
sorry to interrupt. Can we request people if they're not talking to be on mute because there's some disturbance constantly?
Yeah, sure. So yeah, if you're not speaking, you can mute yourself. So in this awk script, basically what we're doing is in each line, we are incrementing the counter in the dictionary by 1. So this ARR will basically be a dictionary where the keys are the lines and the value is the number of times that line is encountered. So we already saw this in the last paper. So in that time we had equals 2, and here we have equals 3. So the concept remains the same. So here we are checking whenever this count becomes 3. So this is not inside the end, but this is also checked in each line. So whenever this count becomes 3 for any line, we print that line. So later that count may also increase to become 4, 5, 6, etc. So at that time we won't be printing anything. But any time like a line is present 3 times at that point of execution, it will be printed. This script will basically be printing all lines in a file that are present 3 times or more. So even if a line is present more than 3 times, this count will sum at one point of execution will be 3 before it becomes 4, 5, etc. So that's why any line present 3 or more times is printed by this script. So that is the option in here. So the lines that are repeated thrice or more is printed. So the second option is not correct, which is lines that are repeated exactly thrice. So if we want that, we have to put this inside the end block. So in the end block, we have to check if the value of this array is 3, and only then we print the key. Right, so hopefully this is clear. So let's move on to the next one. So this again is like the script is totally same. So here what we are doing is we have a script that should basically add the creation time of each file after the name of the file. So here what we are doing is we are first storing the creation time using the stat command. So we are getting the creation time of the file using the %w. So %w is the format that gives you the creation time, and it will be in a format like this: 2022, 10, 20, then the hour, minute, seconds, then the milliseconds, and then the times. So if we then take this, and what we want is only this part, the date followed by a t instead of a space, and then the hour, minute, second. So first what we will do is we will split the creation time by the dot and remove anything after the dot. Only the part left of the dot is taken. So that is done by the first command. So creation time %% dot star. So %% basically removes from the end, and dot star is the pattern. So anything after the dot is removed. And then we only have the first part. And there we are doing a substitution. So we are substituting the space by t. So here we have this space that should be substituted by into t as per the requirement. So then we are simply moving the file which is present in the directory into a new name, which is the file underscore the name, like file underscore the creation time. Okay, so in the first option, we are just substituting the space with t, and we also are dropping the name of the file. So we are just moving the file into the creation time. And in the second one also, we are not doing anything at all, just moving the file to the creation time. So that's why first and second is incorrect. And in the third one, we have done everything correctly, but we have dropped the name of the file, which is not what we want. As you can see, we want the name of the file to still remain when we have renamed the file. So that's why option 3 is the correct option. Right, so the next question is a cron question. So in this, like the time of the execution is changed. So instead of having 10 for the first 6 months and 9 for the last 6 months, we have 9 for the first 6 months and 10 for the last 6 months. So the other parts remain the same. So as we saw, like the 1 to 6 and 7 to 12 for the months, and 1 to 5 for Monday to Friday remains the same. And the date of the month, we actually don't want any constraint on it, so we keep start.
Hello,
and
sir.
Yeah.
This question paper was, I think, already taken, no?
Yes, so that was the forenoon. This is the afternoon paper. So there are some differences. So in the previous paper, we had 10 p.m. for the first 6 months and 9 p.m. for the last 6 months.
Okay.
And here we have 9 p.m. for the first 6 months and 10 p.m. for the last 6 months.
Because similar questions are coming.
Yeah. So that's why in this, the option A is not correct, but option D is correct, where we have inverted the 9 and 10. Right, so let's see the next question. So this again is like the same as the forenoon paper, right? So basically what we have to do is we have to copy back all the files in our backup folder. to the absolute paths, which is stored in a file called files. So each line from that files is read, and there the path is there, and only the name of that file is taken. That is the name of the file in the current folder. So what we do is first we read each line from that files file, and then we basically remove everything from that line from the start till the last forward slash. So for example, if it is a slash a slash b slash d slash e, so everything till the slash of before e is removed, and only the last path name is stored. So this is same as doing the base name on that path. So we are basically taking the only the name of the file, which is basically the relative path in the current folder, and then we are copying that into the absolute path. So wherever that file was accidentally deleted from, we have again backed it up in that same place. So we can basically do this base name of a path in two ways. Either we can use the pound to remove everything from the beginning till the last forward slash, or we can do this substitution, so slash slash, so global substitution, where we are removing all the patterns, which is star then followed by a forward slash. So we'll remove all the forward slashes and all the things before forward slashes up till the last forward slash. So only the last path, like name of the file, will remain after the forward slash. So this is working because there is only files and not directories. So the backup directory contains only files and not directories. Because if it was a directory, then the name of directory will also end with a forward slash. So then it will not work. So this will only work for files. And so hopefully this is clear.
So there's so much of disturbance.
1 second. Yeah, Vasu, can you mute yourself?
I'm in a very silent room, Shan. It shouldn't be.
Yeah, no, I think like you were unmuted for this time. So when you're not speaking, that's fine.
Shan, yesterday you had shown, I think connected to this problem, you showed base
Base name, yeah.
base name. So
Yeah.
base name will give from the right the file name,
Yeah.
and base dir will be exactly the opposite, right? Which is
No,
it will give
it's
the
not.
path.
It's not base dir. It is dirname. So
Dirname, sorry, dirname. Dirname will give the up to that. It will give the path, right? I mean,
yes,
oh,
yes.
yeah, yes.
So basically, if I have, let's say, a path like this, right? So sorry. So this base name will give me D, whereas dirname will give me everything except the D. So A, B, C. So in both the cases, the last slash is omitted. So base dirname will also not give you the last slash, and base name will also not give you the last slash. So basically, if you concatenate dirname and base name, you will not get the original string. You will still be missing that slash. And so it is something to take note of. So in this case, there can be like basically a third option where instead of using this string manipulation, we can use the base name command. So we can do something like dollar base name of the dollar file on the dollar file. So basically take just the base name of the file and copy like from the current directory into the actual path where it should be. And so hopefully this is clear how this is working. So let's move on. Okay, so in this question, this is basically the same as the previous one. So we'll not discuss it again like in detail. So here we have three regexes where the first one matches for the empty lines, so start and end of a line. The second one matches for lines that starts with digits, which is present 3 or more times, and then the line ends. So line consisting of exclusively of 3 or more digits. And the last one is line that consists of any character except a dot or a full stop present once or more. So it will not match empty lines, but that is matched by the first one. So in this only lines, which is let's say empty, will match the first one. Line which contains only 4 consecutive numbers will match the second one, because 4 consecutive is matching 3 or more, so it will be matched. And a line without a dot will be matched by the last one. So it may or may not be exclusively numbers, so the second one may or may not match. But regardless, if it's a line which has any character except a dot, it will be matched by the third regex. And the other options, like a line having a number with a decimal place, will not match any of this. So it is not empty. It is not exclusively numbers because it has a dot, and it will also not match this, which strongly detests dots. So because it has a dot in the string, it will not match any of these regexes. So similarly, we cannot comment just by this description, like a line without a space or line with 3 spaces, because if it has a dot, then it will not match any of them. And if it's a line without a dot matching any of these descriptions, then it will match the third option. So only the option A and then the second last and the third last options are ones which we can basically determine they will always match any of the 3 regexes. So hopefully this one is clear. So let's move into the next one. So this again is the same as the forenoon paper. So here we are basically reading line by line from a data file, and for each line what we are doing is we are echoing that line and passing it to grep -o, and we are searching for the pattern which is tilde iter tilde. So this can be any pattern. So in this case it is tilde iter tilde, and -o will basically just print the occurrences of this in each line, and it will print it on separate lines, and we are basically iterating on that. So we will iterate as many times as many iters are there in that line, and we are incrementing the count. So the count starts from 0 outside the loop, so it is not reset anytime, and it will keep on incrementing. And in each line what we are doing is line equals line and substitute the first iter with the current count. So because this is running as many times as iter are there, so each time if we are substituting the first iter, and we are again storing it as the same variable, so it will end up substituting all the iters in that line. And in the end, then after doing all the substitution for each line, we are printing that line. So this we are then doing for all the lines. So even though we are only using one /, which is a single substitution, still it will not print just the first occurrence, but it will do it for all the occurrences, because we are doing it in a loop. So as many times as the iter is present, we are substituting the iter with the count of that iter. So that's why the option 3 is correct. So the value of count at the end of execution and the total number of occurrences of iter in the file are the same. So the count will basically increment as many times as there are iters in the document. So in each line, as many iters are there, the for loop will run that many times, and the while loop runs as many lines there are. So a total of all the iter which are present in the line in the file, that will be stored in the count. And the fourth option is not correct, which we saw yesterday. So this does not do what this is trying to do. So this is most probably marked as incorrectly. And so let's move on to the next one. So in this, the condition is now different. So in this script, we have
Why fourth condition is not true, sir?
so in the fourth one, we ran this yesterday, right? So this will not be doing what this is doing, because in here we are running the grep inside a subshell. So although like we are getting either true or false, so this will keep on running. So grep -q will only give the exit status and no output. So this will keep on running as many times as iter is there, but we are not giving any file to the grep, right? So neither we have given any standard into the grep, nor we have given any file to the grep. So if you have not given anything to the grep, then grep cannot run a search without telling what to run the search on. Right? So that's why this will not work. Similarly, for the sed, we have not given any file standard into the sed. And even in the loop, as you can see, there is no redirection done. And even if a redirection is done, because this script is running in a subshell, it will not get the standard in given to the while loop.
So wrongly marked as right, sir?
Yeah. So this is this would have been corrected in the after the key was released.
Okay.
Right, so let's see the next one. So in this, so now the conditions are different. So here what we have is again a loop from 1 to 10, but now the f value starts from 1 itself. So earlier we were starting from 0. So in here we are starting the f value from 1, and for all the multiples of 3, we are setting the f to 0, and we are continuing. So basically, if we have the 10 numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the values which are multiples of 3, so I mod 3 equals 0 means multiples of 3. So 3, 6, and 9, for those we are basically skipping the loop. So continue means don't do anything below it, directly go to the next iteration of the loop. So for 3, 6, and 9, we will not be doing anything. And for other numbers which are not multiples of 3, this for if condition will not be true. So the f will remain 1. Right? So f is set as 1 in each iteration again. So f remains 1. And in this condition, we have two checks we are doing. If f is equal to 1, so which will obviously always be true, because whenever we are reaching this if condition, that means we have not skipped the loop because of this continue. And this is the only place where we are setting f to be 0. Otherwise, f is by default set as 1. So whenever we are coming to this evaluation, f is always equals to 1. So the second check is the only thing that is being checked. So here we are checking if I is greater than 5. So if the variable which we are iterating is greater than 5, then again we are continuing. So again for that, we are not using the next echo. So we are not printing anything. We are directly going to the next iteration. So for all the values greater than 5, which is 6, which is already skipped, 7 and 8, we are then continuing. So we are not doing anything. And only for the remaining numbers, we are then echoing star, star, star. So the remaining number is 1, 2, 4, and 5. So in total, we will basically have 4 lines having star. So we will have star, 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 and star, star, star. So the question asks how many lines will be printed after executing the below script. So because we are only for these 4 numbers, we are not continuing the loop. That's why the answer here will be 4. So just let me know if this is clear. So here the f is different. So here this will always be true, whereas in the previous paper this was never true. That's why we totally ignored this condition. And now this will always be true whenever like it's coming to this. So only when this continue is not done, this will always be true. So then we are checking if this condition is true. So for all the values of I greater than 5, we are skipping them. And for all the values of I less than equal to 5, if it's multiple of 3, then also we are skipping. So the only numbers left are 1, 2, 4, and 5.
Excuse me, sir.
Yeah.
Yes, sir. So in this the first loop, the if condition here.
Yeah.
So if we go the number 6, then if we take the model 6, then why it is not considered to take
No,
that?
so yeah, 6 is 6 modulo 3 is 0, right? So 6 is a multiple of 3. So this condition will be true. So it will come here and it will continue. So
That
because
mean the number 6, when we go to the number 6, then it is skipping that number.
yeah. So it is skipping all the multiples of 6. So 3, 6, 9, all of them are skipped. And also any other number which is greater than 5 is also skipped. So 7 and 8 is also skipped. So only numbers which is not skipped are the numbers lesser than or equal to 5 and not multiple of 3. So numbers 1, 2, 4, and 5. These are the only numbers.
And in the list, 10 is also to be included, no, sir?
Okay, yeah. Sorry. So we have 10 also here. My bad. So 10 is also greater than 5. So 10 will also be skipped, right? Because we are simply checking if I is greater than 5 and we are skipping that. So yeah, 10 will also be 10 and 10 will be skipped. Thanks for pointing that out. And so hopefully this makes sense. And so this f equals 0 is basically not doing anything at all. So this will basically, this is made to make it more confusing. So f equals 0, f equals 1, and f equals 1. All these things can be removed and the entire thing will be logically equivalent. So because the f is not used at all in this script. So if we remove f equals 0, the check of f equals 1 and the assignment of f equals 1, still the script will run the same way. Right? So hopefully this is clear how the answer is 4. So let's move on to the next one. Right. So here we have a question where we are basically having 100 characters, which out of which 47 are numbers and rest 53 they are letters or non-numbers. So then on that file, we are running this following sed script. So what is this sed script doing? So the first line, it is, so this is in extended regex, ERE. So the first line is first searching for any digit and it is grouping it, and then it is replacing it with the same digit 2 times. So each digit will be duplicated. So if I have 37, it will become 3377. So all the 47 numbers that we have, it becomes duplicated. So after this, how many numbers will I have? Like if I have a total of, let's say, 47 numbers and 53 characters. So after doing this substitution, so where I am finding any 0 to 9 and I'm substituting it with that same thing 2 times. So after doing this, how many numbers and how many characters will I have?
94 numbers and 53 characters.
Right? So 94 numbers, and it will still remain as 53, right? Because we're not doing anything with the characters. So now we have this many. So then the next step, what we are doing is we are substituting. So S, and again we are searching for a number, but in the search we also have \1. So what we are searching for is a number which is present 2 times consecutively. So any number, like for example, if you have 5 or 2 2, so anything that is present consecutively, that is matched in this sed, and then we are replacing that with \1 and we're doing it for all the matches. So after this, what will we have?
Same 94 numbers and 53.
Same.
Yes, right, because we are not doing anything at all in this. So this second line which we have is totally like useless. So we can even remove this and still the answer will be same. So because here what we're doing is we're matching a digit present 2 times and substituting it with the same digit present 2 times. So this is not doing anything at all. So in the end, we will still have the same number. So we will have 94 numbers and 53 characters. So basically, we will have 47 plus 53 plus 53. Sorry, 47 plus 47 plus 53 characters, which is nothing but 47 plus 100, which is 147. So in the end, we will have 147 characters in like as the output of this set. So that is why the answer is 147. So just let me know if this is clear, how we are getting 147.
Yes, sir.
Okay. So let's move on to the next one. So this is the last question of this paper. So we have seen this question yesterday. So what is this code doing basically, which we saw yesterday?
Standard deviation.
Not standard deviation. Right? It is finding the what is it finding? So it's taking 2 variables, x and y.
Yeah, covariance, and then it is dividing it with
Yeah, covariance or correlation, I think, right? So covariance by
correlation. Yes.
yeah, covariance by standard deviation, square root of standard deviation. So it is getting you the correlation between x and y. So we're then asked what will be the output of this script if it's run on this number. So 5 6 3 4 1 2 7 8. So what is this called? Like how are we giving the input to this directly this way? Like I'm writing the input directly in this command itself, right? Using this double less than symbol. So what is this called? Any idea?
Command line input.
So this is not going as the standard in. This is actually going as a file itself. So this is basically called a Heredoc. So what we can do is we can mention what I want to be given as a doc, and it will take it from the code itself and it will treat as if this is given to this command as a document. So for example, if I do cat and then I do this less than EOF. So now it is basically it will keep on taking input. So the cat command is not run yet. So I'm just mentioning what I want to give to the cat as a document. So this multi-line input is basically done by bash itself. So here I can just write anything I want, and then in the end, basically whatever I gave after this less than, this is basically, so it can be anything. Here I have written EOF. This can be any character or string of characters that we are sure will not come in the text itself. So whenever we encounter it, it means that we are done giving that, right? So now you can see that it is basically whatever I wrote, it is given to cat, right? So and cat prints it. So it's given to cat as the standard input. So
And sir, how the input is taking here? It is line by line. It is taking.
yeah,
Like
so yeah,
every
what like if we give it line by line, so it will also have it line by line. So because this was the first line and this was the second line, we also got it this way, first and second line. So this will be more prominent if we write it in a script, right? So if I have a script here, so it is usually not supposed to be given in the terminal input. So we are basically using it when we want to directly mention it in the script itself. So for example, if I want to put something in a code itself. So this is a here document, hello 123, and we can end it with the EOF. So what this will do is it will take this and it will give the entire thing that I have given here to the cat as a standard input. So here you can see if I now run this script.sh, so it will be printed. So this is because the cat is getting this entire thing that I'm written in my script itself as the standard in. So here instead of cat, if I make it as echo, then what will happen? What will be the output?
then it just shows without taking the line, and then so basically
Okay.
yeah, it will print the output to the command exactly at the same time because it is using the echo command.
Okay. Any
After
other?
the script is run, and then it,
Okay, so let's see what happens. So if I press enter, you can see nothing is printed, right? So this is because echo does not read the standard in at all. So because we are sending this to the standard in, right? So echo will not read standard in at all. So basically nothing happens in this. So echo is not reading at all. So instead of this, if I make it read, and let's say the name of the variable is let's say var1. So now if I do let's say echo $var1, then what will be the output? Anyone?
then it will read line by line, like the first input that this is the year document, and then hello, and then 123.
Okay. Any other options? Any other wages on this? So what does read do? What does the read command do? The read command reads from standard input, right? So this is fine. It will get it from the standard input, but read command only reads one line, right? So if I print this, you can see only the first line will be printed because this is only going to read the first line from it. So when we want to read all the lines, we use read inside a while loop, right? So we do while read, but here we don't have a while loop.
Yes,
We only have the read.
while
Excuse
command.
me, sir.
Yeah.
Sir, won't read minus r var1 work here?
Yeah, so minus R will basically also give you the same output. So if you run this, you'll still get that same. This is a Heredoc. So the only difference in minus R is that if you have, let's say, backslash, right? So if you have a backslash here, then it will correctly preserve the backslash. So it will still have it in the variable. But if you don't have the minus R, so then the backslash will get omitted. So now you can see it shows like this. Right? So that is the only difference.
Shine, if you went back to cat, you had done the cat EOF, right? First one.
Yeah.
And if you put something below EOF, go down to and then write something after EOF.
Okay. So basically, whatever I write here, this will be executed as a command. So let me clear the screen. So this will first, it will print whatever I gave, and then it will say, this is not a command. So basically, if this was, let's say, date, then it will execute it.
So EOF is a keyword which the system knows that I have to read everything before that.
No. EOF is not a keyword. So anything that I type after this will be treated as that. So here, if I, let's say, I have stopped. So then if I just have EOF, then it will keep on reading. So EOF will also be part of the input, date, the text date will also be part of the input, and only when I write I have stopped, it will stop reading. So now you can see it will print this. So EOF is also part of the input, date is also.
Okay, got it.
By default, we use the string EOF because it means end of file, but this can be anything. Whatever
What is
text.
that stream, sir? It is a variable or what we call it?
Which one?
That I have stopped you are written.
So I'm not sure what is the name of this. I think you can call it as the file
Variable.
terminator or something like input terminator. So it terminates, it marks where the input has terminated. Okay, so usually we use the EOF. So EOF is something that is also like a thing which when we are pressing the Control D, right? So that time EOF signal is sent. So for example, if I simply do cat, right? So then cat takes input from your standard in. So whatever I'm typing, it is printing. So you can see whatever I am typing is being printed to the screen. But when I press Control D, obviously you cannot see that I pressed it, but you have to take my word. So when I press Control D, then cat stops taking input and I'm getting my prompt back. So that Control D also basically acts like a end of file. So it means that I have stopped giving the input.
Chan, one last thing. Yesterday, I think we were discussing that. So there is this single less than arrow 2 and 3. Can we just revise that once and what works where?
Yeah, sure. So 1 second. Okay. Right. So the single less than arrow basically means read a file and give it as the standard in. So for example, if I do let's say cat and I do a single bracket and I do let's say data. So here let me create a data file. Right. So now if I do bash test.sh, so you can see I'm getting hello, how are you? So it is reading the contents of the file and it is basically giving it as the standard into this. So this can be any command. So if it is cat, then it is given to cat. This can also be like WC. So WC will print the number of words, number of lines, and number of characters. And so you can see it has 2 lines, 4 words, and 18 characters. So we can basically give any file as the standard input to a command. So this is theoretically same as cat data pipe WC. So I am first printing the contents of the file and that output I am piping to WC. So here we are actually using 2 commands, cat and WC, whereas this is directly handled by bash. So this is a bit faster. So here we are using the file redirection. And similarly, we can use double less than, right? So this we saw just now. So if I do WC less than EOF, so this is a Heredoc. And then if I do EOF, so what happens is now this is directly read from my script and given as standard input to the WC. So here also you can see that it is printing 2524. So this is telling that this has 2 lines, 5 words, and 24 characters. Right, and if we have 3,
Shan, so basically this double is to read line by line. Is that correct? And single is for a file. Can I say that?
Yeah, single will basically, so we are giving the name of a file or path of a file, and it will basically read line by line from that file and give it as standard input. And this will directly read from whatever you're writing next, like in the script itself. And so you can directly write in the script and that will be given as the standard input. So you can basically think of it like doing this. So echo and then hello, and then you just go into the next line, right? So you can do multi-line also this way. So basically you're echoing multiple things in a string and then you're piping that to WC. So this very soon becomes hectic, right? Because we have a opening quotes here and then a closing quotes here. But this is a way, like a more pleasant way of working with text that we want to give. And here, like the benefit of doing this is we can actually interpolate variables. So I can use things like shell variables in this. So if I, instead of WC, if I let me use cat to print what I sent, so you can see that the variable actually got interpolated. So if I'm reading from a file, it will just read the contents of a file line by line. But here I can actually use variables also. So this is for like multi-line string or text along with variables given in the script itself.
So cat less than file name will not work.
No. So less than is not for file name. So
if in the data, if I had a variable, the data file, if I had, let's say, $user, it won't get executed.
no. So for example, if I go into the data and I add the $user here also, right? So if I now make this also as cat, so you can see that it is directly printing it literally, right? So when we are reading lines from a file, like this is basically like the cat is taking it directly, right? So it will not interpolate any variables. Whereas here I am first writing it, so first bash will see this and it will expand all the variables and then it will give it as standard input to this whatever command I have written. So hopefully this is
and the
clear.
third
So,
one, the less than.
so that is very similar to the double less than. So instead of having multi-line, if we just have like one line or one variable that I want to give, that we can directly give to the standard input using the less than. So for example, here also we can use the like variables. If I do $user, so let me clear this. So here you can see this is also getting the like expanded value of the variable, and this is only like used for a single line. So if you want to directly give some string or some variables to the standard input of a command, then you can use the triple less than sign. And so hopefully this makes sense.
Yeah, thanks.
Okay.
So more than one line means double less than, no?
Yeah, because then we can use the EOF to demarcate where to stop.
So single line means three less than.
Yeah. So this is also basically same as doing echo hello user and then piping it to whatever command. So if it's cat or if it's wc, whatever is your command. So this will again be using two commands, right? So echo and then wc. So first bash will expand this, then this string will be given to echo, which will then print it to the standard out. Then its standard out will be mapped into the standard in of this, and then wc will get this. Whereas this is far simpler because directly bash is handling this. So bash will expand this, and then bash will take the string and give it to the standard in of this command.
Cat then hello user also will be the same as echo hello user, right? They'll do the same job. Both will print.
No, if you just give cat and then a string, then that means it's trying to find a file with that name, right? So you have to use echo and then a string if you want to print a string, or cat and then a file name if you want to print a file value.
Yeah. No, I'm saying on the top, cat less than hello $user.
Yeah.
That will print hello whatever username. Even the bottom one will print hello whatever the username.
Yeah. So here I have piped it to WC.
Basically, I got
demonstrating. Yeah. So if you just want to print it, then obviously you should just use echo. But the point is basically if you want to use another command, right? If you want to give some string to another command, so if you're doing it this way, it is running two commands. It's taking a little bit more time. Whereas this way, it will do it slightly faster. So hopefully this is clear. So here we are giving the numbers to this op in the standard input.
Sir,
Directly.
Excuse me, sir.
Yeah.
Can you show me the previous one, the pipe on that? So the pipe one is taking time more because the standard input is first echoing that hello user and then it is executing the WC. But the
So we are using two commands. We are using the echo command and the WC command. Whereas here we are directly, like the bash is directly handling the sending things to the standard input.
So first one is executing at the same time.
Yeah, so both are executing at the same time. So this is also run parallelly, but because creating like running a command and then setting up the mapping of standard out of a command to the standard in of a command, that takes a few CPU cycles, right? So that will take a bit of time. But
No, my question is, sir, my question is that I'm not talking that. My question is that before using that, if so, there is separation between the two command. The pipe one is using the first command and the second command. Both will be executing parallelly, or
Yes.
I mean that first one, the echo hello is, and then the WC is executing.
No, both are executed parallelly.
Okay.
So the standard out of the first command is mapped to the standard in of the second command. And as and when one line is given to the standard out by the first command, it is sent directly to the standard in of the second command. So they are both running parallelly. So let's say you have a command which takes a lot of time, right? So you have a very heavy command which does a lot of processing and it's very slowly giving out one line, then it is giving out another line. So if you have piped it into another command, so it will not wait for the entire thing to finish and then it will start. So that will not happen. As soon as one line is given, it will process that one line. Then again, as soon as the second line is given, it will process that second line. So in pipes, the commands are always run parallelly. So you can also see this if you basically, let's say, run a command which takes a lot of time. Right. So if I run the command tree on the root, right, so this will print a lot of lines. So as you can see, it will keep on printing a lot of things. So it will take a lot of time. So if I do tree on the root and if I send it to grep, right? So here now, if I let's say what is something which might be present a lot of time, maybe I search for the word Linux, right? So now you can see we are getting the output immediately, right? So you can see grep is printing to the screen also immediately. So it's waiting for some times and then again printing some lines and then again it's waiting for some time. Right? So why is this happening? Because the tree is keeping on creating lines, and as soon as one line is created, it's given to grep. So it is both are running parallelly. And whenever grep finds a line which has Linux, it prints it to the screen, and then again it's keep on reading. So sometimes the tree is printing a lot of lines when no lines have Linux. So at that time, the grep is basically not printing anything; it's waiting. And again, then when a line is generated by tree which has Linux, then again grep prints that. So you can see sometimes it is stopping and then sometimes again it is resuming, right? So in piping it is never like the first command is run then the second command is run. Both are run parallelly, but some commands can only print anything only after the entire input is got, right? So if you think like in a data structure and algorithms way, you can only sort input only after you know the entire input, right? So if you just know the first and second line, you cannot sort the input. You need to know the all the lines, only then you can sort the input. So if I run the sort command on this, you can see there is no output being generated. So both of them are running parallelly, and sort is told that, okay, this is the first line, this is the second line, this is the third line. So tree is giving it the lines one by one. But sort is like, I don't care, I will not start anything unless you give me the last line. So give me the last line, then tell me that you are done, only then I will start working. So sort will not even start doing anything unless the entire command has finished. So only when it gets all the lines, sort will start, and then it will obviously sort those lines internally, and then it will print the entire sorted output directly. So there are some things like searching, like which we saw using grep, which can obviously be done line by line, because searching can you can just see if one line contains something, then print that. If that line does not contain something, then don't print that. But sorting will need to read the entire thing. Similarly, if we use the unique command, so what the unique command does is it will remove any duplicates present consecutively. So it will not remove any duplicates present non-consecutively. So if I have, let's say, uh, something like, hopefully this is visible. So if I have something like A, B, A, so it will make this as one single A. So it will become A, then B, then A. So if I save this as data 1, and then if I, sorry, if I run unique on this data 1, so you can see the first two A's will be squeezed into A, and but the last A will not be removed, right? It only removes the sequential like similar lines or same line. So thus unique can again work line by line. So you can see when I run tree unique, it will give the output immediately, right? So tree is keeping on creating outputs, and unique is also keeping on printing the outputs. And only when it finds two consecutive lines which are same, it then basically will not print the next line. It will only print the line once. It hopefully this makes sense. When you're running two commands in
Why I'm asking this question, sir? Here, what in my mind is like in OPP one question, like we are using that tr command to squeeze the space
yeah
in between the line. So that's why I'm thinking that okay, it will execute first and then executing after 5.
yeah No. So it will also do it line by line, right? So because you're giving multiple lines to TR, so it will take the first line, it will squeeze any repetition, it will print it to the standard out. Then it will
Yeah,
take the second line.
more time because we are executing 2 commands. That's why only. Right.
Yeah. So even if you execute, let's say like multiple pipes also, like some command and then so A, then B, then C, then D, all of them are run parallelly. So it basically just creates a mapping of standard output of A into standard in of B, then standard out of B into standard in of C. So they will wait if there is no standard input. So let's say like working this like through this, it takes some time. So A takes maybe 1 second, B takes 1 second, C takes 1 second. So D will take 3 seconds to just get the first line of input, right? So that way it will take time. So it will wait. So the process is running parallelly, but it is waiting to get any input. But how many ever pipes we have, they are always run parallelly.
I got it, sir. Thank you.
Yeah.
Thank you, sir.
All right. Yeah. So in this question, you can see that the input given to finding the correlation coefficient is this 5, 6, 3, 4, 1, 2, 7, 8. So here also in this question also you can see that the values are different, but still it is like x and y is also x plus 1. So we have 5 and then 5 plus 1, 6, 3 and then 3 plus 1, 4, 1 and then 1 plus 1, 2, and 7 and then 7 plus 1, 8. So here also the first column and the second column is totally like linearly dependent. So second column is just first column plus 1. So in that case, the correlation coefficient will obviously be 1. So even without doing the calculation, you can get the answer to be 1 in this case. And so if you're not familiar with like this is the formula for correlation coefficient, you can also like go through it, right? So you can do this entire calculation for the entire data, and then also you will obviously get the same answer, which is 1. But if you are like familiar with it, then it will be even faster. And hopefully this makes sense. So this is the last question of this paper. So we have now done the 2022 September, both the FN and the AN paper. So in the next sessions, we will basically be finishing the other papers of the 2022 year. So just let me know if there is any doubts in this paper.
Sir, in interim exam, what is the
Yeah.
most probability that we have to focus on